Okay, next session, progressive delivery. Haven't heard that one before, I think. So please welcome Kevin Dubois from Red Hat.
Thank you, thank you. All right, so yes, we're going to talk about progressive delivery and how we can deploy our applications in a nice, gradual, automated way with a lot of control over how the deployments go. But we'll get there kind of step by step because we'll start from where I started, which is kind of like this. That was my first continuous integration, if you will. I don't know if you recognize this, this happens to be FileZilla, but FTP in general, just copying files over to production, and that was pretty much it. We're live on production. That was, of course, a while ago. I hope it is for you too. If not, yeah, good luck, I guess. Anyway, so then we moved on, right? And we moved, we started using Git, which was already pretty fancy and advanced. Yes, we came from Subversion and from some other stuff before that. But Git allowed us to have a little more control over, at least we could see who committed something, and we could, take our releases and roll them back in a little bit of a more automated way. And so what we did back then is we used rsync to roll out to different instances of our servers, and that also was very fascinating. Just copying your files over from server to server. Yeah, lots of late nights, weekends working, trying to fix bugs and trying to figure out what was going on, and then we wrote some crazy automation scripts. But yeah, that was good times, and then we moved on to maybe a more real CI/CD. In that case, with Jenkins, and Jenkins treated us, relatively well. But Jenkins also has its own special struggles, especially if you have a lot of plugins and everything. But I think everybody can maybe recognize this, right? So with CI/CD, you build your project. Hopefully, you have some tests in there too. Maybe even some security checks, and then you'll create some sort of a release. And then, you'll deploy maybe in some semi-automated fashion to staging, and then to production. And most organizations do this, especially this last step in a manual way, right? Where somebody still has the button that they push to actually go to production after everybody's coordinated that it's safe to deploy to production, and then maybe the release will go well, maybe not. But this is great if you have one application. But what if you start having a more distributed architecture? Then that means each of these applications need to be deployed individually. So you can see here kind of all these little tubes represent little pipelines for each project. So now you need to manage, all these different projects individually, and doing all this manually, that doesn't really make sense, right? So we want some sort of flow of going from our code, developing on our local machine. Of course, we still need to do that and maybe do some local testing, some debugging and everything, and that happens in what we call the inner loop. And then at some point, we'll create maybe a pull or a merge request, and then we enter this outer loop where again you have some processes to automate this cycle as well, right? So in terms of building the application, assigning the application, creating the software bill of material, and doing some more testing, and then automating those deployments, and that's what we call the outer loop. So this is kind of what we wanted to go to, and yeah, that's kind of what this talk is about. And so we have the kind of the exact same process of CI, and you see here CI/CD, CD, because we have both continuous delivery, but what we want to go to is continuous deployment, where we go to production without kind of that manual person step that kind of becomes maybe a bottleneck. So before we go on, I want to kind of demo how we can automate a release, but of course I need an application to demo, right? To show how we're going to release an application. So this is a little game that that my team and I developed, and that you can participate in. So hopefully you'll participate on your phone by tapping on your phone, and I'll explain how it works. So basically, there's this dashboard, right? And you see the two little cars. So we're going to do a car racing game. And I'll show a QR code, and then you scan it, and then you'll see what's on that left side. You see a little windmill, because of course we want to create green energy to power our cars, right? And so we're going to make the windmill go by tapping on our phone, and that's going to make the windmill spin, and that creates energy, right? In reality, it creates events, right? Of course, that get sent to the application, and that's what my dashboard is going to read to make the cars go forward. So maybe a little sidetrack here from the continuous integration, continuous delivery, progressive delivery. Just a little word about the application itself. So it's based on Quarkus. I'm a huge fan of Quarkus, and basically, when you scan a QR code, you'll get to pick a team, and I'll tell you what the team names are in just a second. And then you'll register your name into the system. And then once we start the game, you'll start tapping on your phone, and that sends a request to a REST endpoint. It gets put into a Kafka topic. And then on the dashboard, we'll read the events from the Kafka topic. And so the front end as well is part of the Quarkus application. So there's a Quarkus extension called Quarkus Quinoa, which allows you to combine your regular Java build with your NPM build as kind of one build. So you just do Maven package, and it's going to do your NPM build too, which is kind of cool. So that's how it works. So team one that you can pick, and I'm going to try here, shut Buller, more or less. Yeah, so we're going to have a team that's, the fans of the meatballs. And then the other team, so I was asking on Twitter, Gravlox is something that I know. Is that a good name? Is that kind of a funny name? And then several people said you should replace Gravlax with Surstrumming. And so I'm like, okay, I just looked up what this Surstrumming is. Sounds pretty interesting. I saw some videos, fascinating stuff. And then Sébastien Blanc said, oh, the winner can get a can and is allowed to open it in the conference room. And then Matthias or Jean, I don't know which one it was from the JFocus team, was like, no, that's where we draw the line. That's not going to happen. Anyway, so yes, so team two is going to be team Surstrumming. And so you can pick which team you want to be part of. We'll take the average of everybody playing, and that's how we're going to play the game. So hopefully some people will pick one team and some people will pick the other team, but it's up to you. All right, so let's see if it works. So if you want to scan the QR code, and then hopefully you'll see an option to pick your team, and then you'll see a little car spinning if everything goes well. So let me know if, do you see it? Okay, good. And then hopefully our internet will be good enough. So I'm really dying to see how many people are going to be on which team. Okay, so if everybody's done scanning, it's kind of hard to see with the lights here. See a few people still trying to scan. Okay, so the source code of the game is here. That's not so important. I have it deployed on this Kubernetes cluster, an OpenShift cluster, and here's the dashboard of the game, and I'm going to just hit refresh. Make sure that we load everything. Come on, internet. Oh, the live demo effect. Well, this is fascinating. I like that everybody can see the other side of the game. Okay, I'm going to close this. I have another version running, so I'm going to go here. Let's try this. Okay, and then go to the dashboard. Oh, if I can type. Dashboard. That was interesting. All right, so I think we have a pretty good, we have 97 people on Team Surströmming, so all those people are going to actually eat it after the session, right? I want to see, and then, even 100 and 118 on the Chudbuller team. Okay, so I'm going to hit start, and then, just start tapping, and the windmill is going to go, and then we're going to race. So 3, 2, 1, go. All right, so go ahead and start tapping. Yeah. Ooh, it's getting close. All right. Nice. Good job, Team Surströmming. I figured those people would be the most motivated. All right. And who was player with the username Judis? Nice. Congratulations. You can go to the Red Hat booth and get a Red Hat hat. And everybody else can too. All right. So now we have a game, right? An application, and I would like to do a new release. I want to develop a new feature for our game. So what if I added a new feature to this game? So to make it more realistic, right? So because we're creating this moving energy, so instead of tapping on our phone, I want to make it so that we use the accelerometer of our phone so that we have to shake our phone. And so that's how we're going to power our next game. And so, me as a good developer, what I do is I, write my code, and then Friday afternoon, that's when I commit it, of course, right? That's how you do it. And then I'm like, oh, here, ops, go ahead and deploy my application. And ops is like, there's Kevin again. And so, yeah, anyway, let me do some coding. It's going to be some really intense developing here. So here's my application. And like I said, so we have the backend code here with our Java, with our Quarkus code. And then I also have the front end code. So here's a configuration file in JavaScript. So this is React. And you can see here's our team, the two different teams. And I'm going to just change a little feature flag. So I'm going to turn off tapping. Oh, that's not. Is that AI? Okay, stop. Don't. My mouse is, when it's is connected sometime to an external screen like this, sometimes the mouse is a little slow. Anyway, so I'm going to save this, and we're going to commit it. Change to shaking, and then, of course, I'm going to commit straight to my master branch. My mouse wants to come on, like jumps away. Okay. Let me refresh this. If not, I think I can just do it straight in the GitLab too. That's where the code is, so main. I'm really struggling with my mouse here. All right, web UI. And then source, config, come on, edit. Sorry, this is like slow motion. This is okay, false. It's so quiet here. And we're going to commit it. Come on. If I run out of time, this is going to be the reason why. Okay, commit straight to master. And so after I commit this code, I have a hook that's going to notify my automated build that's going to kick off a pipeline and then deploy my application. But before we dive into that, let's do some more slides first about exactly how that works, right? So, and you know how it works, right? When you implement a new feature, especially at 5 p.m. on a Friday night, nothing will go wrong, of course, right? We all know how that works. So again, we have our developer flow. So what I did was I committed my code, and yes, I did some testing locally. I did, maybe not. I pushed my code, and now we're going into this outer loop of actually building the application. We're going to go through some security checks. We're going to run through some tests, and then we're going to automate our deployment to our development environment. And so we're going to use continuous integration as, kind of our first step. And, with in my title, I said kind of next-gen CI/CD. So instead of using maybe a more classic Jenkins, we're going to use serverless CI/CD. So basically, that allows us to use the cloud. And for every step of our pipeline, we can create a container, run our task, whether it's build our application, whether it's building a container image, signing the image, deploying. Those can all be self-encapsulated tasks that spin up a container, run it, and then scale back down. So there's no resources really being used other than the exact task of our pipeline. So that's kind of the idea behind serverless continuous integration. And so we're going to look at how that works with Tecton. So who's heard of the project Tecton here? So we got quite a few people, which is great. So Tecton is a project part of the CD Foundation, and it allows you to create, declarative CI/CD by basically declaring, in the typical cloud-native fashion that's in YAMLs, right? And so you define exactly, like how do you want your pipeline to work? What are the specific tasks? And then you can chain those together into a Tecton pipeline. So here's an example of a very simple pipeline. And yeah, of course, we're going to be talking about cloud native and Kubernetes, so I'm going to show quite a bit of YAML, but I'll guide you through it a little bit. So in this case, we have a pipeline, and you have just a set of tasks, and that's how you define those. You can also use a UI to build this, so you don't necessarily need to know exactly how this works in terms of writing. And then in terms of the tasks themselves, you can use parameters. So for example, if you have a git clone task, you can actually reuse that across different pipelines, different runs. All you do is just add in as a parameter, for example, your Git repository. And then, so Tecton uses a Tecton hub. So you have a whole bunch of tasks that already exist, so you don't have to reinvent the wheel. And then you can reuse them between different pipelines as well. So you have very reusable components. They run as containers in a Kubernetes environment, and so you can have a nice automated process using Tecton. And then once we have our application built, we need to deploy it in some automated way, right? So this is where Gitops comes into play as kind of a way to save exactly how, in a Git repository, how you want your application configured, how you want it deployed, what it should use for configuration and everything, and you save that all in a Git repository exactly the same way as you would with your code. So Gitops basically means that Git is your single source of truth, not just for your application, but also for your environment, for how that application should be configured, for everything. And then, so you can treat it, your operational stuff the same as you would your code, right? And so that allows you to use the same Git workflow that you would use for your application. So you can use, merge requests or pull requests to say like, hey, we want to deploy our new version. Here's the definition of it. And then somebody can review it. And what's nice too is that we can always see who changed something, when they changed it, and we can see what they changed. So our production environment, our test environment, we can see exactly what it is without actually going to the production environment, and vice versa. If somebody changes something manually in our environment that we didn't check into Git, well, then this GitOps engine is going to tell you, like, hey, that's not in sync. Your desired state and your actual state are not in sync, so somebody did something that they're not supposed to, and then you can roll it back if you want. So the difference between CI/CD that we see with with Tecton and GitOps is basically that with CI/CD you have a one-way street, right? So you go through your pipeline, you go through your steps, and at some point your pipeline is done. GitOps, on the other hand, it monitors constantly between your desired state and your actual state, and then mitigates that to make sure that that always matches. Or it can notify you that it doesn't match. It kind of depends on how you want to use it. So those two together make it into a really nice system where you can automate everything. And so we'll see that. I'll show you that in just a second in the rest of the demo. So what we're going to do, and I guess what I already did, was I committed my code change, right? And then that kicked off a CI pipeline. And my CI pipeline went through a bunch of things and then created a container image and pushed that to an image registry. So let's take a look at that. So I have a Tecton instance running here. So this happens to be in OpenShift. So OpenShift integrates Tecton as Tecton pipeline. So gives us a little bit of UI sugar on top. But you can see here, this is the pipeline that in the meantime already ran. And we can see that it did a git clone, packaged our application, did a scan with SonarQube, and then built our image, signed it, created the software bill of materials. So it did a bunch of stuff, right? So each one of these little boxes is a task, and that task corresponds with a custom resource in Kubernetes, but it also corresponds with a container that starts up, runs that task, and then scales back down. So in this case, we can see there's a green check mark. It ran, and it scaled back down. And so we can see that it did a bunch of things. It signed the image and then pushed it to a registry. I'll share the source code so you can take a look at this if you're interested in automating a pipeline like this. Because these days it's important to also know kind of the provenance of our, all the libraries that are in our application. Where is the image? Was it signed by you? And so that somebody doesn't go in and starts doing things with your container and even inject something in your pipeline, right? So this is Tecton. And then at the end here, we basically updated our repository that has our desired state. So this was the repository, as you probably remember from just now, that had my application. And we also have another repository which contains some Helm charts. In this case, it could be just regular Kubernetes manifests that say, like, hey, I want 5 replicas of this application. This is where you can find the source image and stuff like that. And it would then update this, my pipeline would then update the source image with my updated value. So that's kind of how that works. And so ArgoCD is the implementation of Gitops that I'm using. And so we can see that it would then automatically roll out our new version once it notices that our desired state has changed. So in the meantime, hopefully, if everything went well, we went to our version 2, and now instead of tapping, we're going to be shaking our phones. So wish us luck with that, right? So just to kind of recap, right? So we committed our code, we went through this CI/CD pipeline, pushed our container image, and then it could be a pull request or a commit to update the configuration of our desired state with our new desired state, which is a new container image. And then the the Gitops engine notices that, oh, there's a change in our desired state. So then it's going to roll out our application automatically to Kubernetes. So let's see if it worked. So scan the QR code again. This is a different environment because I wanted to make sure that we have a working version of our version 2 in case something went wrong. I'll play too. Which team though? All right, I'll do source strumming too. And so you'll see that it shows enable shaking, so tap that. And then I think if you're on iPhone, maybe you need to give permission for the accelerometer. And then we should see that it's waiting for the game again. So if everybody's done scanning the QR code, and make sure, sorry? Sorry. Yes, yeah, I will show it on the screen. So if everybody's done scanning the QR code, and this is a different one than the one from before, so make sure you scan it. Okay, we'll go to this implementation of the game. Oh. Now we have many different versions. Prod. Maybe our prod version wasn't working. Okay, let's see. Okay, well, it won't let me log in. If not, maybe we can just use the previous version because I think it did roll out with our new version. So I'm going to share the other QR code again. Let's do it that way. Come on. There we go. We'll go back to the previous slide with the previous QR code. Okay, sorry about that. I'm going to make sure that it works too. Okay, I see the enable shaking. That's good. Okay, so go ahead and scan the QR code if you haven't yet. If you're ready to shake your phone, make sure you hang on tight to your phone. Don't throw it. That has actually happened to me. Fortunately, it was in my own home office, so the damage was limited. Okay. Just going to hit refresh here to make sure that everything loads. Okay, so we have 110 on the team surstrumming, then 124 on shotbiller, and then I'm going to hit start, and then start shaking your phone, okay? So 3, 2, 1. Okay, go, 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 go. Come on, team surstrumming. Oh, it's a very tight race. Go, go, go. Oh, there's a little bit of a race condition, no pun intended. All right, but the meatball team, the shotbiller team got their revenge. Good job. Was it the same time? Wow. So it was a tie, basically. Okay, so everybody can go to the Red Hat booth and get a hat. All right. So that was our game, and basically we had an automated process of running through the CI pipeline, signing our images. That was all done. We verified the provenance and everything. Of course, I have limited time, so I can't. I didn't show that in too much detail. But now we're going to move on to actual. The progressive delivery part of our talk here. So, by the way, I was 101st only, so good job with the shaking. You guys are pretty good. So, what happened is I released our game, and so we went through our pipeline, and our Gitops engine noticed the change, and then it did do a rolling update. So it does, in the Kubernetes fashion, we have 5 instances, 5 pods running, and so it updated the first one, and then the second one, and then eventually routed traffic from one version to the other. But it did that kind of as a one-shot release, right? It was kind of a big bang release. Instead, it would be nice if we could do a more progressive delivery and then kind of see, like what is actually happening with our application. Let's roll it out gradually. And then if something goes wrong, we're not impacting everyone, right? So that's kind of the idea behind progressive delivery. So it's not a big bang release. And it means that deploying is not necessarily the same as releasing, because we can deploy our application to production, but not send our traffic yet to our new version. And so that's how we can have control over, how the application is rolled out. And then we're going to rely on metrics to actually see, how is everything going with our application, and not just, kind of, well, I'll try to see if everything goes well, but actually use like metrics that we're getting from our system. And so we can roll out to a subset of our users to see how everything is going. So why would you use progressive delivery? Of course, the ideal thing is to limit the downtime. So when we release something, that only a subset of the users are impacted at the most. So we limit the tragedy of the release, and then hopefully not be, up until 5 in the morning trying to fix things and make that process a little less painful. And that should, by automating, by having more control and more visibility into our releases, that also allows us to deploy and release to production faster, because we have more confidence that if something goes wrong, that we can handle it gracefully. And it also allows us to do less mocking or setting up kind of these unreliable fake services, but because we can actually use our production as perhaps even a testing environment. So let's talk about some delivery techniques on how we can accomplish this, right? So the first one is basically what we've already seen, and that's what most people are probably familiar with, is the regular blue-green deployment. So we deploy our new version, which is in green, the second circle there. And once it's up and running, then we shift our traffic to our version 2. And then, if everything goes well, then we can delete our version 1. So that's how it works with blue-green deployments. And then we also have canary releases, and most people are also familiar somewhat with canary releases, right? So you basically send traffic to, in this case, 10% of your users, see how everything is going. And then if everything goes well, then we can shift our entire traffic. And so you do that in a more gradual way, which is, a little better in terms of the impact to your users. Then there's some other techniques that you could use as well in terms of releasing. So for example, dark launches. So one example is mirroring your traffic. So you release or you deploy your second version. You're kind of duplicating your traffic between the two versions, so you can see exactly how your application is behaving under a real load without your users being affected. Of course, you need to be careful of, if you have data behind it, that you're not also duplicating your data in the back. So, be mindful of that. But it is an interesting technique to do, some testing to see how it actually behaves in real life. Then you can also use feature flags, of course, where you can say, well, based on this flag, send the traffic to this version. Based on this flag, send it to this version. So Victor here I guess it was at Vox Days Bucharest, and I thought this was kind of funny. He's also talking about mocking and testing, and he's like, sometimes, mocking is out of control, right? I mean, in this case, basically the production code has 4 lines of code, and there's 20, 30 lines of mocking just to test those 4 lines. And sometimes it's like, well, it's crazy, because now you need to maintain those tests and you still don't know exactly if it's the same as production, right? So it makes more sense in that case, well, maybe, use one of those techniques to also use production as a testing environment. And then, maybe our testing pyramid, even though totally does not look like a pyramid here, can be a little bit different, right? We can actually incorporate production as part of our testing, where we can do certain load testing, certain integration testing on production. But testing shouldn't end by just during the deployment phase, right? We should keep monitoring and seeing how our application behaves when it's actually used in production as well. Use that data to optimize our application, and also maybe, if it's not good enough, that we can automatically roll back. So how can we accomplish this progressive delivery? Because that sounds pretty cool, that we can automate deployments and automatically roll back and automatically scale our traffic to our new version and stuff like that. How can we do this? So of course, it's a lot easier with Kubernetes, because you have pods, you have that you can scale, and that you can send your traffic back and forth pretty easily. So blue-green deployments, even though they're not really progressive delivery, but blue-green deployments you can do with Kubernetes pretty easily. Yes, we're going to go through some more YAML, but you can see here that you have a deployment in Kubernetes that points to a service, or rather a service that points to a deployment, and then basically at some point you update the service to point to a new deployment, and that's how you can kind of switch from one version to another. Canary releases you can kind of do with Kubernetes as well. So you can say, here's my service, point to 2 deployments at the same time, and then you have a certain amount of replicas, a certain amount of pods running for this version, and the other version that corresponds to the percentage of traffic that you want to send between the two. So in this case, you can see version 1 has 3 replicas, so 3 pods that can accept traffic, and then version 2 has 2, and then the service basically will go round robin by default, I think, between all those different versions. So, kind of by design, 25% of your traffic would go to your version 2. But that's not really so ideal, right? You need some better way to route your traffic and roll out. So there's a few different ways that you can do this. One example that I'll use in my demo is Istio, so it's service mesh. And, so service mesh basically allows you to do more intelligent routing and load balancing of particular components, particular microservices in your Kubernetes cluster. So, and it also allows you to, for example, do dark launches, so mirroring traffic. It can do all those things by defining that in your service mesh. It's not super easy to configure, in my opinion, but it is really powerful. So if you haven't, checked it out, definitely do. And so, for example, a canary release with Istio, you can do it this way. So you define it as a virtual service, and then you set, for example, well, I have my version 1 where I set the weight, which corresponds to percentage, to 75%, and then 25%. Send it to my version 2, and so it automatically routes the traffic based on what you have configured there. And then the same way, for example, if you want to shadow your traffic, so if you want to mirror your traffic, you could say, hey, version 1 is where traffic should go, but also duplicate traffic to version 2. So you can define that pretty easily with virtual services in Istio with service mesh. And then you can also do, for example, like, hey, if the headers match with, in this case, Alexandra. So Alexandra gets to test version 2, and everybody else still uses version 1. So you can define that pretty easily as well with Istio. But it's still kind of a manual process, right? Because somebody has to maintain these YAML files and then update the values to change the traffic or mirror the traffic. Which, yeah, that's not really progressive delivery in the sense that it's not automated. So how can we do automated progressive delivery then? So there's this really interesting project out there which is called Argo Rollouts, which is not ArgoCD. So we saw ArgoCD, which is the Gitops engine that monitors your defined state, your desired state, and then synchronizes that with your production environment. This is also an Argo, but it's Argo Rollouts. So it's the same kind of project behind it, but it's a different tool that also uses ArgoCD, by the way. But so Argo Rollouts basically can integrate with different components. So you see the little sail there, that's Istio, so you can use Istio, but you can also use, Nginx or traffic, or there's a bunch of different ways that you can, route your traffic, right? So it can integrate with those different tools to, and then automate the actual values of those rollouts. So where we saw before, like 75 and 25, I don't need to change that manually anymore. Argo Rollouts will actually do that for me based on what I tell Argo Rollouts to do, which we'll see in just a second. And then it can also integrate with monitoring from, for example, Prometheus or Datadog. There's a bunch of different providers that it supports. So with Argo Rollouts, yes, we also need YAMLs. But in this case, you can see, for example, a rollout custom resource definition where we can see that you see there's a specification and there's steps. And so you see step with set wait 20, then a pause, in this case for 1 minute, and then set wait to 50, and then maybe pause for 2 minutes, and then so you can define steps to roll out your application, and so it'll do that, right? So for example, with Istio, then it's going to change that value automatically, respecting those pauses. So in this case, what's going to happen is I'm going to say, well, I want to roll out this new version and send 20% of my traffic to this new version. And then pause for 1 minute, and then we can check and make sure everything is going well. And if so, then it's going to just keep rolling out, and then to 50%, and then blah, 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 until, of course, you're at 100%, and then our rollout is good. But we want to make this a little bit smarter still, right? Because if I have to, during that pause, have to manually go check and see if everything is going well that's not how it should be, right? So we want to make this smart in the sense that if something is going wrong, that it can roll back, and if everything is going well, then it can continue rolling out. So that's what you can also do with Argo Rollouts. In this case, you would just add an analysis template to your definition. So in this case, for example, there's a template called success rate, and in that template, we can define where it needs to go and check for metrics to see if our application rollout is going well. So in this case, you can see like every 10 seconds, make sure that at least 95% of all my requests have a good status code, and if not, count that as a failure. And then we can define how many failures can happen. So in this case, I've defined it to 2 times. So if I get in my metrics 1 time that there's some errors, keep rolling our application out. But if you find that 2 or more times something is going wrong, then abort the release and roll back automatically. And so you can see here, for example, a Prometheus query that we're using. So in my case, a very simple one. I just look for 500 errors. But you can make this into whatever you want, what makes sense in your environment based on your metrics. And so that's how you can really automate the whole thing. And no AI at the moment, but I'm guessing that Argo Rollouts project is probably also working on some AI features to make this even more interesting. Anyway, let's see how this works with a slightly different little demo. So unfortunately, this time you don't get to participate. Also because we're starting to run towards the end of our time here. So in this case, I just have this little fancy looking thing that shows the color yellow boxes. And so every time one of those boxes appears, it basically makes a call to the back end, make sure that, if there's no error code, then it's going to return the value of the color that it comes from a container image. So I'm going to start watching my rollout here. So I'll make this a little bit smaller, and I'm sorry that could be a little bit small for you in the back, but bear with me. So I'm going to roll out a new feature now. So I'm going to go here And this is a very kind of simple change. So it calls this, this image, and based on what the image is tagged with, it returns a different color. So instead of yellow, let's do red. And so I'm going to commit this, change to red. I'm going to push this, and that's going to, of course, make our ArgoCD notice that my desired state has changed, right? Because this is my configuration of the application. I want it to point to a different image. And so our ArgoCD here, which is here, I'll make this a little bit bigger for a second. I'll refresh it. And so it notices, hey, your desired state has changed. I'm going to sync it, and I'm going to start rolling out our new version. So I'm going to make this a little bit smaller so you can see the little animation, and we can see that, you know, the color red is starting to appear. So what you see here on the left is that 2 new pods were created for our color red, and it's going to wait for a little bit to gather some metrics that it's all inserting in my Prometheus instance, and then it's going to start checking. So you can see here that an analysis run is running, and it's checking for errors. And so it looks like the first time it did see saw more than 5% errors, right? Because I want a 95% success rate. And so you can see that there was a little red X. But I did set it to, you can actually error out one time, but not more than one time, because I know the sample size the first time it checks is a little bit small, so it can have some false positives. But we can see now it's doing continuous checks to make sure there's not too many errors. And if everything is going well, then it's going to keep rolling out, right? So you can see that more and more pods are being created here until you know, everything is going well. We've rolled out to 100% of our traffic. And in that case, we're going to scale down the old pods, and because all our traffic is going to the new pods, and then our release was successful in this case. So, you know, fortunately, we didn't have too many errors. Everybody's happy, so we automatically and gradually rolled out. Now, in production, in real life, you wouldn't do this like in the 1 minute or 2 minutes that I did it. You would, you know, like take maybe a day or maybe an hour or something to make sure, you know, like everything is going well. But in this case, we have to be a little bit quick. But you can see now the old pods were rolled out. So let's try that again. Let's try it again one more time. Let's roll out to blue. But this time I'm going to create some errors. Change to blue, and I think we're running low on time, but git push. And I'm going to start, once we start seeing our blue here, might need to sync. There we go. It's really hard to see when it's so small. Close this, refresh. Okay, so we're syncing, and then in our demo here, we're going to start seeing blue, probably. There we go. And so I'm going to hit this blue, and I'm going to say, start generating some errors. And then we should see that our rollout analysis that's going to start running is going to see errors at some point. And again, if it sees more than 2 times that there are errors, then it's going to roll back, and we're going to go back to red, so to our previous version, right? So we got our first run, our first analysis run here, which has a big X, and now we got it 2 times, and I think it's maximum 2, so we should see 1 more time, and then it's going to say, oh, we're aborting this release, we have too many errors, which is happening right now. You see status is degraded, failed, and so it's going to shift all its traffic back to the previous version. So in a moment, we'll see that all those squares are turning back red. So we didn't have to do anything to roll back our release. And so we have more confidence that if something is going wrong, that everything is going well. So hopefully this gives you a little bit of an idea of how progressive delivery works. So of course, there's a little bit more about it, right? Because yes, we need to think about state and we need to think about, the data that's behind it. So there's some ways that you can go about that. So, when you do create a new version, make sure you try not to make destructive schema changes so you can roll back. Use maybe the event-driven architectures. You can maybe look into Debezium to work, to synchronize with classic databases and turn those in events. But overall, do your releases in a step-by-step way, embrace Gitops, and then, if you haven't automatically destroyed something, then you aren't automating enough because it is going to happen. There's a link to some of those demos, and I'll share a QR code with the slides as well. There's some free books that we at Red Hat, that Red Hat is nice enough to sponsor our books, and so you can download them for free, which is pretty cool. So I think there are 2 Gitops books behind that link, and there's if you're a Spring developer, there's a Quarkus for Spring developers book, so you can come to the cool side of things. So with that, I think that's it. And apologies, I'm 2 minutes behind, but the QR code is a link to the slides if you want to review all those crazy YAMLs. Be my guest, and definitely let me know what you thought of this session. And if anybody wants to show a video of them opening a can of that surströmming inside JFocus, don't do it. Don't. I don't want to be responsible. But anyway, let me know. Oh, and then one more thing. On the 7th of March, there's a Modern Application Development Roadshow where I think we'll also, the Red Hat Sweden team, you can actually try out Tecton and ArgoCD in a lab. So, come talk to the Red Hat people here, and, you can sign up for that free thing. So, and that's it. So thank you, and I'm here for questions. So.